All right, well, good morning, everybody, and welcome to this Cassandra Developer Workshop. And, as a matter of fact, I'm seeing some folks. We're just going to give some folks here a moment to get the Twitch link. I'm seeing some chatter in the Discord, and then we will get started. I see Cedric has just popped the link in there. And hello, everybody who is on Twitch, Discord, YouTube Live, wherever we happen to be streaming today. Like I said, we're just going to give people a moment to get onto their streams, and then we will get going. Okay, so it looks like I see people are grabbing, they're getting on the Twitch. That's wonderful. Alex, how's that how's the YouTube look? Do we see anything there? Yeah. Okay, wonderful. All right. So it looks like from what I'm getting, it looks like we've got folks that are joining the session. That's great. I'm going to go ahead and get started, and we'll still give time for folks to trickle in. So first things first, I am David Jones Gilardi. You can see me there on the left-hand side. I'm a developer advocate here at DataStax. And with us today, we have a cadre of folks from DataStax. We have Jack Fryer, who is our community manager. You're going to see some messaging that I'm going to talk about to send to Jack to get some special stuff for you guys to show up today and everything. So he's going to be our main contact point for you guys. And then in the background, another one of the advocates, and I hope I get his name correct this time, is my colleague Alexander Volochnev. And he is the person who's handling all the wonderful audio, video streaming and stuff like that in the background and keeping this live. So, by the way, if you guys run into any issues whatsoever with the feed, please let us know in the Discord chat. Okay, so then first thing I want to say here. So, obviously everybody right now, everybody's pretty much aware of COVID-19 and what's going on as far as that goes. And we understand from DataStax, we understand that, that can mean a lot of extra load and such on your Apache Cassandra databases and such. Maybe you need some extra help, right? So during this time, if you have an Apache Cassandra database out there, even open source, whatever, and you need help at all, then we're offering office hours and Cassandra cluster health checks at no charge. So if you do have something like that, if you've already got existing Cassandra implementations, you need some help, go to keepcalm@datastax.com. Send an email to keepcalm@datastax.com, and that they'll go ahead and contact you, and you guys can work that out. By the way, I'm getting some messages, just so you guys know real quick, that folks they're reaching the capacity in Discord, so I'm going to send some of these folks over to Twitch. Give me just a moment. You probably saw that pop up on my screen. There you go. All right, and I had another one. Let me make sure these folks are... Okay, good. All right, coming back. All right, so with that. Okay, so what is our plan for the day? What are we going to actually do? So first thing we got to do is, today, this is a hands-on workshop. We are going to get our hands a little bit dirty. We're going to get into some CQL. We're going to, play with the Cassandra database and everything. So we do need to bootstrap up our environment and get everybody, the ecosystem that you're going to be working in. Then we're going to take a look at the what, why, and when of Apache Cassandra. Some of you guys may be completely new to it. Some may already have some knowledge, but to really understand what Cassandra does for you and why it's so cool, we need to really kind of delve into that. Then the third section is probably and arguably the most important part of what you're going to learn today. If you're coming from the SQL or relational background, we've been doing things from the data modeling perspective for a certain way for decades, right? Now, it's not that different in Apache Cassandra but there are some differences. There are some things that you have to look at a little bit differently. So we're going to go through those and kind of explain what those things are, so then you can properly data model for Apache Cassandra, and then we're going to follow up with all sorts of resources and such for you guys to be able to use. Okay, so the first part with the bootstrapping. So to give you an idea of what this environment today is going to look like, right? Now, the cool thing is, from your standpoint, we don't have to install anything like that, right? It's literally going to be your browser and Discord, right? Now, from the browser standpoint, do me a favor, don't use IE. You can use anything else. The reason why I say that is because later on, as we're in the exercises and we're working with Studio doesn't really work well with IE. It doesn't, IE doesn't play nice. So Chrome, Firefox, whatever, just not IE. And then we're going to use Discord. So for those of you who are listening online, if you're on the Twitch stream or if you're on the YouTube piece and you don't know about Discord, I'm going to want you to go. There should actually be a link down at the very bottom. Yep, yeah, I see it. I'm looking at it now. At the very bottom of the video in the stream, you should see a link. Go to that link to get yourself on the Discord chat. This allows you to interact with us. So if you've got questions, things are clear, whatever, come and interact with us on Discord. Then the second part here is going to be GitHub. So everything that we are going to do today is in a GitHub repo. It's all open and everything like that. So whether it's the slides from the presentation, whether it's the exercises in the studio notebooks, all of the materials, they're going to be on the GitHub repo. I'm going to show you what those are as well. So we're going to be working out of there today. And then finally, DataStax ASTRA. So we're working on Apache Cassandra. DataStax ASTRA is DataStax Cassandra as a service in the cloud platform. What's cool though today is when we work with this, we have a free tier, right? And the free tier, that database is going to stop indefinitely. So we're going to set up your ASTRA database today. We're going to use that to do the exercises and go through the material. The cool thing is when we leave here today, that stays, right? That's not going anywhere. So you're able to then follow up and do more work on this. We have a lot of bonus content in our exercises, things you're probably not going to get through to today, and that will allow you to follow up and do whatever you want in the future. Okay, so let's take a look at Discord. I'm going to come out of full screen here for a second. Go back a slide. Whoops. Go back a slide. And let's take a look at Discord. I want to point some stuff out here. No one say anything terrible, because now you're live on here and I just told you that. So a couple things to note about how to use Discord. So other than the main chat that you guys are in now, where we are chatting here, you'll notice that there is a questions channel. So the first thing I want to point out is the main chat is going to be a place where we're going to start dropping some links. As we go through the materials today, we're going to be dropping all sorts of information in here for you. So we ask that if you've got questions or anything like that, that you don't ask them here in the main chat, because with this many people on there, when we're dropping down links and resources, we want people to be able to access those. So the main chat is going to be the main place that we're going to interact with you from that standpoint. If you do have questions, however, just click on questions and ask a question, right? And this is going to be the area. We actually have a whole set of folks that are on today from DataStax that are here to help answer your questions. So if there's something, maybe you have a clarifying question, maybe you want more details on something, go for it and ask in the questions room. And then finally, if you scroll all the way down past all of you wonderful users, you're going to notice these breakout rooms. So what's really cool about these is, let's say that maybe you have a question that you've asked in the question room, but it needs a little deeper explanation, or let's say that you're having some technical issue or something, you need some help. You can go ahead and go to one. All you have to do is click on a breakout room. You click on one of those, and you'll have full audio, video, screen sharing capabilities, and then you can talk with someone directly in the breakout room. All right, let me go back. Here we go. So I can see. I'm going to put this back in my spot. There we go. Okay. All right, wonderful. Okay, so the first thing we're going to do is which is called exercise 0. So let me put exercise 0 in here for you. Okay, hopefully you should have seen some materials just show up in the Discord chat. In particular, you're going to notice there is a link here. You see me, I drop this into the chat. You're going to see there's a link here. This is the GitHub repository. We're going to be working out of this today. So let's go ahead, and everyone, if you could do me a favor and please click on that. Now, there's two ways that we can really work with this. If you are familiar with Git and you want to do a git clone, you can totally do that. That's the command that you see here. Or if you just want the materials and you just want to be able to work with them, if you see up on the top right-hand corner here where it says clone or download, if I click that and I say download zip, it will download a zip file with all of the resources, all the artifacts and everything like that. Then once this downloads, I'll give it a moment. There it goes. I'm going to go ahead and open this. I'll explode it. You can see maybe I've done this once or twice before. Oh, I just got how to copy the link. So you should, if I go over to the Discord, you should be able to just click on it right here. You should be able to click on it, and boom, it should launch a new tab for you. If not, you also can right-click on it and say copy. Let me know if that works for you. Okay, so then we download the file. I've exploded it. Here's really what I want to point out for today. When you've exploded this, or if you did get cloned, you're going to notice a notebooks folder and all these notebooks, 2, 3, 4, 5, and it has these names. So while we're going through the material today, I will be calling out, and we're going to be dropping it into the Discord as well. I'll be calling out which exercise to use. Now, I'm going to explain to you how to use these, but for now, especially for Windows users, it's probably better that you just download the zip. And when it comes time, we're literally just going to be able to drag and drop these into our studio and work with them. So get it for now, and we will move on from there, and then we're going to use these later. And last part, if you would notice here, hopefully you guys can see my screen. Notice that you can add a reaction to one of the exercises. So for this exercise, if you would, and this is how I'd like to go about letting us know that you're able to, that you've gotten through the exercise and you've done what we need you to do, right? Is if you add a reaction, thumbs up, sparkles, smiles, whatever, right? And you can see that you get a reaction that shows up down here. This way, it lets us know when we drop the exercises that you guys have been able to do exactly what, boom, I saw one happen. Excellent. Thank you. Yes, I see the numbers going up. That's wonderful, everybody. That's exactly what I'm looking for. All right, great. So I'll give a moment just to okay, and I do see that there are a set of people who need the link in Twitch, so I'll give them a moment as well before I move on. Yep, okay. And the GitHub link here, I will drop it again. There you go. You should see the GitHub link. Notice when I drop these exercises in, you'll see this URL at the very top of that. And the GitHub link is right there. I'll also give it to you this way. There you go. All right, I'll just give, again, everybody a couple more minutes, or a minute anyway, to grab that GitHub, get the files. Okay. All right, give me just a moment. Hey, Cedric, can you drop the YouTube link in there as well? If you can't hear anything, I stopped talking for a moment. There you go. Yeah, okay, Cedric's got some links. There we go. All right, and I do hear the Twitch stream. Okay, and while we're waiting for folks, and I see links being dropped in, one last thing, if you notice at the very bottom here, it says chat with us on Discord or send us an email. So this is something special for you guys. Is it a thank you to you for all showing up here today. We're going to give you, if you so choose to have it, a voucher for a free certification, a Cassandra certification exam. These right now cost like $375, right? So we're going to give you a voucher to do this completely for free to be Cassandra certified. So to do that, either direct message Jack Fryer. You can see Jack Fryer at 4525 on Discord, or just go ahead and email him at jack.fryer@datastacks.com, and we will put that information in the Discord as well. But make sure to reach out to Jack, ask for that voucher, and that way you can get your certification. Okay, so just a little bit about ASTRA before we get that started up. So ASTRA really, if you were looking for a case, especially from a developer standpoint, ASTRA was really developed with the developer in mind. If you are looking to be able to leverage the power of Apache Cassandra and what it can do for you, in the past, you kind of had to spin one up on your own, right? There's a lot of extra work that's involved with that. ASTRA is a fully managed Apache Cassandra service up on the cloud. And it has all sorts of tools that are really there to help enable developers. You're going to work with some of them today. It is meant to be able to get your application hooked up to your database like very quickly. So to kind of remove all the barriers. And again, we're going to work with that today. For those of you who are familiar with SQL, if you've not been introduced to Cassandra before, we use a language called CQL. You'll see that here on the left-hand side. It should look and feel almost exactly like SQL. That's on purpose, right? And then for those of you who are also familiar with Cassandra, ASTRA is no different. It is Apache Cassandra, right? So we're going to be using SQL as far as the language goes. From the DevTools standpoint, we're going to be using a lot of Studio today for our exercises. Studio is a Jupyter notebook-like tool, so if you're familiar with that. And we're going to go through all the capabilities there. And then from a driver standpoint, pretty much if you have any main coding language out there, whether it's Java, C#, C++, Python, whatever node, they're all supported with the unified drivers that are supported by DataStax. So that's the Apache Cassandra OSS. Whatever versions of Cassandra, those drivers are the same drivers that you can use. Okay, so with this, the first thing we want to do is go to exercise 1. I'm going to pop this down into the chat. There we go. You should have seen in the Discord chat, I just gave you an exercise. So what I'd like you to do is we're going to do this together. I'm going to do it with you, but if you click on the link in the Discord, right? So I'm going to do it. If you notice, I'm going to go to the Discord. Here's the link. Boom. Click on that. And we are going to follow this together. Okay. So if you follow me down here, you're going to notice the very first thing. We have a link up here. Go to astra.datastacks.com. This is where we're going to be. I should have middle clicked on that. My bad. There we go. This is going to be the first place that we are going to start. Now, if you see a screen like this, if you have not registered, make sure to go and register. It should just take a minute. Otherwise, if you have registered, wonderful. We're going to go ahead and log in. So I'm going to log in because I already have an account. And then I will ask all of you to go ahead and register if you haven't already. We'll give everybody a moment to do this. This is all free, by the way, right? So there's no part in here where you should have any kind of payment information or anything like that you need to put in. Okay, so here's the goal, right? What we're looking to do is we want to get to this screen, right? Once you register and you log in, you should get to this screen. And if I could get a thumbs up from folks when you get here. And again, I know it's going to take a moment for some folks to register. Wonderful. I see a thumbs up. Excellent. And just let you... That's a lot of thumbs up. That's wonderful. Cool, guys. All right, awesome. Okay, so looks like a lot of people are getting to the screen. That's wonderful. That's where we need to be. So what we're going to do is we're going to follow the instructions here and what we need to do. Now, at this point, you've gotten through the registration piece. You see this form. Here is the key thing. When we fill out the information here, you want to use the free tier, right? If you start to use the other tiers or anything like that, you're going to notice that money is going to become involved. We're using the free tier today, so make sure you have the free tier chosen. And again, this will stay up indefinitely, well past today, so you can follow up with things later on. Then you're going to want to select a region. Now, I'm in Florida, so I'm going to use US East. Obviously, if you happen to be over in EMEA or something, you want to use Europe, so use a region that's closest to you. Now, this next part, for today, I ask you to use exactly the values that we have here in the document. You're going to see the database name, key space name, username, and the password. So I'm literally going to cut and paste these in. And this is important because as we go through the rest of the exercises and all the work we're going to do today, if you use something different, these aren't going to quite work the way you expect. Now, when you go to use your own ASTRA and you go to play around with it or something like that on your own, you can call these whatever you want, right? But for today, we are asking you to fill out these values. So again, database name, killer video cluster, key space name, killer video. Notice the camel casing here and the username, same thing with the password. Once you guys get to a point like this, you're going to see you have a launch database button. We're going to say launch database. And this is just going to give you some information. Let's say view. This is the screen right here that I want to see. So we want to get you all to this. Now, you may have noticed in the message, it says it can take upwards of 30 minutes to start these. Honestly, generally speaking, it's usually a minute or two, but there are some cases where it might take a little longer. You know, what we're going to do is we're going to start these and we're going to move on. But like I said, it should be relatively fast. And this is the screen that I want you to get to. Okay, and mine actually just got created, so you can see it went active. All right, so I'll give everybody just a couple minutes to get to that point again where you see this green bar. Good, I'm seeing you guys are already giving me thumbs up. That's wonderful. Great. And then we will come back to that later. Okay, hey, I see some folks for my helpers that are out there. I see some folks that aren't able to see the screen. I'm assuming that they don't have the link for one of the streams. You are seeing a message. Here, I'm just going to put this so people say, I apologize that I'm putting it in caps. Oh, he's got it, yeah. Yeah, the database details, yeah, I can bring that back up, no problem. Here you go. So again, we have all right, we'll give just a couple folks. Alrighty, all right, so let's move on. Okay, so now I want to get into, while we wait for everyone's Astras and stuff like that, I want to go ahead and get into the what, why, and when of Apache Cassandra. So Cassandra is a NoSQL distributed database. So what does that actually mean? So NoSQL, you know, not only SQL, this is not a relational database. It's not an Oracle or a MySQL or something like that. And by distributed means that by its very nature, there are actually multiple nodes, multiple instances that comprise a database. It's not a single instance. Now in a single node, roughly speaking, right, can handle about a terabyte of capacity and around 3,000 transactions per second per core. Now these are rough. This is totally dependent on the type of hardware that you have for an individual node, right? But generally speaking, you could look at something like this. And notice that that's transactions per second per core. And by today's standards, most machines, we're not running Pentiums anymore, right? Single machine or single processor Pentiums or something. You know, they're going to be multi-core machines that we spin up, whether it's in the cloud or on-prem or something. So that is transactions per core. Now in Cassandra, though, like I said, it's not just a single instance. It's actually a whole set of instances. This is what we mean by a distributed database, right? So you have multiple nodes that comprise a single database. And these nodes communicate through a protocol called gossip. Now, why does this matter? Well, because there's certain things that you're going to learn about today, whether that be like token ranges or like the status of a node, things like that. And the nodes, they communicate. And so they know, oh, okay, which node owns certain token ranges, or is this node up or down or something along the lines. And this is done in a peer-to-peer fashion. It's an organic system. So as I add and remove nodes into the system, they will automatically start to communicate and share information. We also then group nodes into data centers. You'll see a ring here that just formed in the image, right? And this is a data center. Now I can have more than one data center. We'll talk about that later. But for now, just imagine here, I have a single database that is comprised of multiple nodes that are in a data center. That would actually be my database. Now, something really cool about Cassandra is that it is linearly scalable. What does that mean? Well, that means that if I need more capacity or if I need more throughput, I can just add more nodes. So what this chart's showing, if you take a look at the x-axis there, and you see number of nodes 4, right? You see roughly operations per second, 100,000. What happens when I double it? Well, now I'm sorry, 50,000. What happens when I double it to 8? It's near 100. What happens when I double it? You're going to see that as I double it, right, that it is near linear, right? And this holds true for clusters that are even much larger than 32 nodes, right? There are even installations out there today that are thousands of nodes, and we see that this holds true. And this is actually one of the really cool things about Cassandra is it effectively allows you to scale out indefinitely. So what this comes down to and how it does this is what's called horizontal scaling. So I think most of us who work with databases to some degree, we're used to vertically scaling. What do I mean, right? I mean, like, okay, I need faster disk, or I need more processing power, or I need more RAM, or whatever. And we vertically scale up the instance to make it more powerful and faster to be able to meet our needs. The joke that we generally have with Oracle is you can scale up until you run out of money, right? But at some point, you're going to hit an upper limit. And what Cassandra was built to do was to scale out horizontally with lower commodity hardware right out of the gate. So in the case of Cassandra, if you want to double your capacity, or if you want to double your throughput, you double your nodes. So you can see here on the left-hand side, I've got 3 nodes. If I want to double that capacity and that throughput, I can just double and so on and so forth, right? And I can do this on, again, smaller hardware for each individual node without having to vertically scale so large for each individual node. And then data is distributed, right? So we said it's a distributed database. So what does that mean? So if you take a look at the table on the right-hand side, and notice that we have some country-based data here. I have something called a partition key. We're going to talk about what that is later. But if I take this data as I'm inserting data like this into my database, that data is going to get spread around my database. It's going to be spread nice and evenly around the whole database, right? So this is distributing the data. And by the way, this actually happens automatically. This isn't something you have to do manually or anything along the lines. So how does that work? So imagine we have our ring. Each of those circles is a node. Now each node is going to be assigned what are called token ranges. Now in this particular case, this is a very simplistic illustration, right? So we have token ranges that go from 0 to 100 effectively. Now in the real world, the token ranges, the actual size of the amount of token ranges that you have is like an astrologically, did I just say that? Astronomically large number. Yeah, I'm going to get made fun of for that later. It's huge, right? You're not going to run out of those tokens. But again, for illustration purposes, it's just easier to look at it like this. So what we're seeing here is that each token or each node owns a range of tokens, right? So in this case, let's say I'm going to go from 0 to 16 and 17 to 32 and so on and so forth, right? So each node is going to own a range. So when data comes into the system, right? When I want to write some data into the system, let's say I've got some data that's going to come to partition 59. What happens is a node is going to get a request, and that node will become what we'll label it as the coordinator node. Now, something important to understand about Cassandra is that it is a masterless system. There's no boss node or anything. Any node can do what any other node does. So the coordinator node, all it means, it's the node that is handling this request. So I have a request for data to come in at partition 59, partition token 59. Some node, this one labeled 83, gets the request. It's now labeled the coordinator node. That node is now going to forward that data onto whatever replica owns that particular range. So in this case, it's going to go, okay, well, remember I gossip, I have information, they communicate, so it knows what ranges each of the tokens has. And it's going to say, well, guess what? This partition token 59, it fits into the range of this node down here that you see, from 51 to or 50 to 60, 66. So it's going to forward that data onto that node. And whatever nodes that data lives on, the ones that it's forwarded to, those are called replicas. So I want you to notice something. In the first case here, I had a single ring. This is called replication factor 1. Now I just added replication factor of 2. Notice that I added a ring, right? I went from 1 ring to 2 rings, and I shifted it. So now what this means is I actually have 2 nodes that can cover a particular token range. So what does this mean when data comes in? Again, some data comes into the system. Partition 59, I'm going to write something to it. Now I want to point out, now this node up here, this one labeled 17, that's the one that's getting the request this time. So that now becomes my coordinator node. What it's going to do, it's going to go, okay, well, I've got this data for partition token 59, and I need to forward it to where it goes. Replication factor of 2. I now have 2 nodes that cover that particular range, so that data is going to get forwarded to both those nodes. That's what you see here. What happens in replication factor 3? Boom. I add a ring on, I shift it. Now I have 3 nodes that own this particular token range. So can you imagine what might happen in this particular case, right? What's going to happen? I get the request to write some data. Again, partition token 59. It comes to what is now my coordinator. That is going to forward it on to the 3 nodes that now own that particular token range. So this actually offers up some really cool benefits, right? So not only is the data distributed, but I actually have multiple nodes that all house the same data. So one of the benefits this comes into play with is what happens in a failure scenario, right? What happens if one of my nodes is on fire? Something happens, it goes down. Well, I still have 2 nodes that have that data. So if I get a request that comes in, my data can still be forwarded on to the other 2 nodes. Not only that, if I get a read request, I still have 2 nodes that can facilitate that request with the data. Something else cool that happens though. Notice what happened here on the right-hand side. You're going to see this hint, right? So this is another one of those robustness features that is baked into how Cassandra works. So if I have a node that's down, whatever node was acting as my coordinator at that time is actually going to store a hint for that data. What that does is it says, okay, that node is unavailable or it's down or something like that. I'm going to store this data just for a moment. When that node comes back up, I'm going to replay the data and the node will automatically be updated. So this is a self-healing function that Cassandra has. This also translates into the fact that I have now 3 nodes that actually have the same data. So what does that mean for my reads? Well, when I go to read data, I don't just have 1 node. I actually have multiple nodes. Think about from a performance standpoint. Now I actually spread the load amongst those 3 nodes, right? So from a performance standpoint, it's better, and from an availability and robustness standpoint, it is also nice to have. So I mentioned before that you can have more than 1 data center in Cassandra. You can have n number of data centers. And what's really cool is when I create those data centers, that actually comprises a single database. So if you take a look at the left-hand side, what does this translate into? So from a geographic distribution standpoint, let's say that I have a need, which pretty much all of us today who are writing applications, we have customers and clients that are all over the world, right? Nobody pretty much has anyone who's just in one particular physical location anymore. And the physics that get in the way of the time it takes, the latency. Like if I have a data center that's say in the West Coast, but I have a whole set of users that are in Australia, there's a huge amount of latency between that. And by today's standards, right, that's just too much latency. So I want to be able to put my data as close to my users as absolutely possible. So what Cassandra allows you to do is I can have multiple data centers, and those can be spread all over the world. And that's what you're seeing here. So I've got a data center in the West Coast. I have one in EMEA, and then I have one over in Asia Pacific, right? So these 3 data centers all comprise a single database. And what this means is, as if I write data, let's say over to a node that's on the West Coast, that data will automatically be replicated out to my other data centers and will automatically be available in the other data centers. So I could write something in the West Coast, and then I could read it immediately from China, right? And that replication is completely automatic. As a matter of fact, when you create your key spaces and stuff, we'll talk about that later, you're actually setting your replication factor. You're setting how replication works right there at that point. From that point, this is all handled for you. There's like no ETL, there's no manual file copy. This part's being done, right? So this means that I have a single database that actually can span the globe and put my data locally where it needs to be to get to my get to my particular users. Now, on the right-hand side, you're going to see a case where we are talking about Cassandra really from a deployment standpoint is totally deployment agnostic. It doesn't care where you put it. It could be on-prem, it could be in the Google Cloud, it could be in Azure, it could be in AWS, it could be in any cloud provider, it could be in a combination of those. So I could have a single database, and that's what I'm depicting here on the right. I could have a single database that actually spans not only 3 different cloud providers, but on-prem for a multi-cloud, or hybrid multi-cloud scenario. I could have whatever combination there, and that one single database will live in all of those. Now, why might you want to do that, right? So what we've actually found a lot is vendor lock-in, to prevent vendor lock-in. So if I have data centers that are, say, in Google Cloud, Azure, and AWS, I have a lot more leverage with those particular providers in billing and all sorts of things, because I can just move away from one to another no big deal. Or what happens if there's, say, some capability that you want to leverage in only Google Cloud, because it's the only one that has that capability? Well, you can go ahead and stand up a data center in your database, have the automatic replication do its thing, and now I've got that data available there in the Google Cloud, and I can leverage those particular capabilities. But what it really comes down to is Cassandra is ultimately very flexible. It's deployment agnostic. It doesn't care where you put it. And so that allows you all sorts of options as far as how your database exists, as far as geographic distribution or in a cloud scenario. Okay, let's just pause for a moment and let's do a deep dive into the CAP theorem. I'm kidding. Now we're just going to very briefly touch on this. So the CAP theorem, if you're not familiar with it, basically states in any distributed system, if you run into a failure scenario, you can only maintain 2 of the 3 items you see here: consistency, availability, or partition tolerance. So let's take an example. Let's pretend for a second I have 2 nodes, right? And then I have a network partition and they can no longer talk. Well, those nodes are up, they're available, they both can facilitate requests, right? But I may not be able to be consistent if they can't talk, right? This is actually what Cassandra defaults to. It defaults to what's called an AP system, availability and partition tolerance. So this is why you might sometimes hear Cassandra is always on and available, right? It's by default, it's built to be available no matter what, right? Now, you can configure it per query to act like a CP system, where it actually puts the focus on the consistency piece. Now, in the example I gave, if I had 2 nodes, right, that had a network partition between them and they could not talk, I would not be able to maintain consistency in a case like that. So if I did have a query that was, say, configured for a CP-like need, then at that point it's going to fail. It's going to say, hey, I cannot maintain this kind of consistency. But if you want to, stick with the defaults, which most people do really, where it focuses on availability, then that means that your database is always going to be up and it can always facilitate requests no matter what's happening between nodes and such. So let's take a look at consistency levels. So we talked a little bit about replication factor and what that means. And by the way, I just want to state, you see on the left-hand side, we have an RF of 3, a replication factor of 3. You'll notice that in the examples I gave, I talked about replication factor 1, 2. You could have a replication factor of 20, right? But the standard across the board is a replication factor of 3. So what I'm going to essentially say to you now is, for your own databases, use a replication factor of 3 unless you have a good reason to do something else. And that gets into a kind of a more advanced set of knowledge, right? So replication factor of 3 is going to give you that really nice balance between availability and your performance and so on and so forth. So consistency level is based off your replication factor. So if I have 3 nodes that I am replicating to, consistency level of 1 means I'm going to wait for an acknowledgement from one of them when I perform a write. Let's see what this looks like. So let's say I've got some data. I'm going to write some data. And now my replication factor tells me how many replicas I'm going to write to. So no matter what my consistency level is, I'm going to write to 3 nodes. That's what the replication factor 3 is saying. Now, all of those nodes are going to send an acknowledgement back to the coordinator to say, hey, the write was good, okay? But in a consistency level of 1, I'm just going to wait for one of those to come back before. So whatever first one gets back to the coordinator, and then I'm going to go, okay, my write was good. What about quorum? So quorum means majority, right? So in a replication factor of 3, what's a majority? 2. Okay, so I'm going to have some data. I'm going to write my data. Again, my replication factor is 3, so I'm always going to replicate to 3 nodes. But in the case of quorum, I'm now going to wait for 2 of those to send an acknowledgement back that they got the write before I say everything is good to go. And the last one here is all. What do you think is going to happen? Anyone? Anyone? I'm going to watch the cord now. No, in a case of all, right. So I'm going to replicate the 3, but now I'm going to wait for all 3 of them to respond back with their acknowledgments. Now, something I want to point out here, we don't recommend to use all. Here's why. Imagine the scenario we had where we lost a node, right? Well, if I lost a node and my consistency level is all, what's going to happen? I'm not going to be able to achieve that consistency level. So what that does is it means I'm going to give up my availability for this dogmatic consistency, right? There is a better way to do this. So we don't recommend ever using all. I just show it here from an illustration standpoint to help understand what this stuff means. Okay, so by standard, the de facto standard for what we call immediate consistency is going to be to read and write a quorum. This is going to offer a really nice balance between having some availability tolerance. So in this particular case, I actually could have one node that goes down, and I can still maintain my quorum, right? And if I want to ensure that when I write data, I read exactly the data I wrote, I'm going to read and write a quorum. It's called quorum. So this is the standard, quorum. Can you read and write it one? Can you do combinations of things? Totally. But again, that's going to get into more advanced usage. So I would say for your applications, generally speaking, if you read and write a quorum, you're going to be at a really good spot for the way that Cassandra works to ensure that you're getting the data that you expect and you have some availability tolerance if a node goes down or something like that happens. Okay, so let's look at some use cases. Where are Cassandra's sweet spots? Right now, I want to be clear, this next section, it's not an exhaustive list. There are more things, but this should hopefully give you a really good idea. So for one, if you have a scalability use case where you have very high throughput or high volume with heavy reads and heavy writes, things like IoT, time series event streaming, that's a very solid Cassandra sweet spot, right? That's something that we see actually quite a bit. From an availability standpoint, right? If you have mission critical apps and you need to ensure that you have a database that's always going to be on and available for you, again, that's another spot where you will see that Cassandra hits a nice sweet spot there. A distributed, as you can imagine, it is a distributed database, right? It has this automatic replication. So as I already talked about, like say from a global presence standpoint, this actually comes into play really neat in a case of, say, like GDPR. So for those folks in EMEA or anyone who's had to deal with this, you know exactly what I'm talking about. I have my database that spans the globe, but I don't have these GDPR requirements everywhere in the globe. I just have them in a particular area. So how do I deal with that? Cassandra has built-in functionality that essentially allows you to manage your data. Even though data is being replicated out, you can manage the security mask, if you will, for the data in different data centers. So it's really nice and flexible from that standpoint. And then last, from the cloud native standpoint. So if you have a need where you do have on-prem, or you've got on-prem and some cloud, or you have a multi-cloud scenario, Cassandra supports all of those, right? So again, like I said, this is not an exhaustive list, but it gives you an idea of some of the use cases that really hit a really nice sweet spot when you're talking Cassandra. Okay, so with that, let's go to exercise 2. I'm going to go ahead and pop this in the main chat. All right, so I'm going to do this along with you. At this point, what we want to do is we want to go back to our ASTRA. Now, there's a good chance because of security, it probably timed you out if you were logged in. So we're going to log back in. We'll do this together. Good, I see some thumbs up already. Back? Okay, I switched up my battery this morning for that very reason. I don't know what just happened. My headset just died. Anyway, I'm back. Sorry about that. Okay, so you guys should hopefully be logged in. And if you were able to follow the instructions before, you should see something like this. if I go ahead and just click on my database, you're going to see a screen that looks something like this. So, and I see lots of thumbs up coming through. That's wonderful. What we want to do is we want to launch Developer Studio. Okay. At this point, you want to use that username and password that we used in the beginning. So that's going to be KV user. Again, notice the camel case and KV password, and then say test. To take just a moment. Excellent. Thank you. Yeah, I'm seeing the message. Thank you. Let me know you can hear me. I appreciate that. Okay. And then say save, and you can do this. Now, you should have a screen that looks something like this. Now, I'm going to drop the link again. Again, if you downloaded, I'll pop this up. If you downloaded the zip from GitHub, then you should have a file like this. This is actually one of the coolest features. I love this about Studio. So you can take, these are Studio notebooks. That's what these are. You can literally take this and just drop it right on there, and boom, you're gonna load it up. So we want to get to this point. And again, I'm going to do this part with you. The whole purpose of this particular exercise is to get through and understand how to use Studio and everything. So I'm gonna do it with you guys. Okay. First thing I want to point out. Now, what I'm not going to do, I'm not going to read all the text, right? I'm going to walk you through it. If you guys go through this on your own, totally, you're going to read the text. So I'm going to just bring you through it and show you what we need to do. So the first thing I want to point out is this big old red arrow, right? What are we telling you about? The way we've designed these exercises is every one of them is completely self-contained. So later on, as we go through the exercises, if you get behind or if you came in late or something like that, don't worry about it. You're totally cool. Each exercise can be run completely independent on its own. So to do that, you'll notice that in the beginning of all of our notebooks, we have what looks like to be this empty cell, right? What I want you to do right now is click that run. When you do that, you're going to see a little bar over here. It's going to start processing things. So if I look at the code, what we're actually doing is we're just creating some data model here. Now, this one is actually very minimal. When we get to the next exercise, I'll show you, there's a huge data model in there. But this is just us making it very quick and dirty to be able to get in, create the data model, and go. And as we go through the notebooks, at any point, if you completely fat finger something or if you mess something up, don't worry about breaking things. All you have to do is come back to that first cell and just rerun it, and you'll be good to go. All right, so hopefully you guys are seeing this. We're seeing the success. You guys ran this. In the future, you're not going to see this big red arrow, and I'm going to point it out, but just make sure you run that first cell. Okay, so first thing here is the Markdown editor. So in Studio, you have two different modes, really. You've got the Markdown and the CQL mode. So in the Markdown editor, that's what we're looking at here. This is where you can use the Markdown language, and this is actually nice if you want to put in, say, instructions, images, things like that, right? And to use it, notice at the bottom you have this hello, your name goes here. So here's what we're going to do. In the top right of any cell, you're going to have this little I for the code editor. So I'm going to click that off. You're going to see the code. Now I see the Markdown. So if I scroll down, all I have to do is edit this and mistype my own name and then hit run. There it goes. It'll execute. If I turn off the code editor, I scroll down, I should see hello David, right? Or hello, whatever your name is, for your particular case. All right, and that just lets you know about the code editor, and we're not going to get into Markdown. That's not the purpose of today, but to give you an idea of how to do that. Okay, so other cell operations that you have. You'll notice in the top right-hand corner of any cell, you're going to have this little ellipsis. You're going to have a whole set of operations. So if you want to move cells up or down, if you want to clear your results, I find that's actually nice and useful, especially if I'm iterating through development and queries and stuff. I get to clear the results, redo them, such like that. I can delete a cell. I think it's pretty obvious when you start reading them. If you want to maximize a cell, you're going to see these two arrows that come apart. If I click on that, it'll maximize the cell. If I click on it again, it'll minimize it. That's nice if I want some more real estate. As I mentioned before, there are different modes you'll see under language. So I have both Markdown and CQL here. And we're going to get into CQL in just a moment. Also notice these plus signs. If you see these plus signs that are through, that allows me to add a cell. So at any moment I can add a cell in and I can add more Markdown or more code or whatever I'm going to do. Okay, so what I'm going to do here is it already chose CQL for me. That's the instruction that I'm going through here. What I want to point out is notice the difference. Notice what happens when I go to Markdown. Okay, notice I just have a run. But when I go to CQL, I have a key space, and then I also have a run, but it gives me consistency levels. So you notice there are different options depending on what I'm doing, right? And that'll become important later. Now, for what we're doing today, the defaults are going to work just fine. We're only working out of a single key space, that is killer video. But if you were, if you had other key spaces in your, Cassandra database, then you could switch between them that way. You can also fully qualify. I'll talk about that regardless of what's in here. But just notice that there are some other options. The default that we're going to use today is what you see, this local quorum. There are other options. You could use a consistency level of 1, local 1, things like that. Really, what I want to point out is this trace. We're not going to do tracing today, but from a development perspective, I find the trace extremely useful in certain cases, especially if I'm trying to trace down what a particular query looks like. The trace is really nice from that standpoint. Okay, so I'm actually going to move this down. All right, so the next part, now that we have a cell, right, we're going to start using some CQL. First thing we're going to do is do this describe key spaces. Now we put it here already for you. You should see a cell that looks like this, and I'm going to say run, and it is now going to execute that query in CQL, and great, we see the key spaces that I have. You'll notice this message here. There's nothing wrong with it. It just means that the describe commands are really meant to be used in CQL/SH. Studio is just telling us that, but it works, so it doesn't really matter. So just ignore that, really. Okay. Now in the banner up top, you have the banner that's all the way up top. A couple things to note. One, the hamburger menu. So now ASTRA, like I said, in ASTRA, we pre-configure your Studio notebook. So you don't really need to do a lot from the configuration standpoint. It's already been done for you. But the one feature I definitely want to point out is this export. This is so useful. So let's say you've done a bunch of work in a notebook like we have here, and now you want to share that with a colleague or a friend or something like that. You just say export, and that's what generated these tar files. That's where these come from, right? It makes it so simple to be able to share notebooks and share work and everything. So that is a really nice feature. You'll see the name of the notebook up here. You'll see the connection menu again. Since we're working with ASTRA, this has been pre-configured. But if you were using Studio with other Cassandra, you could have multiple connection types. You see the Schema Explorer. We will use this today. So if you click on that, and by the way, if you happen to see that little bar right here, just refresh. And then we go to the Schema Explorer again. You should have the expected thing. I'll pop it open. There we go. Use killer video, and this will be a way that as we go through the exercises, we get to explore our schema. Yes, you can use describe commands. That's totally fine. You'll find that for more general information, the schema viewer is really useful, right? And we're going to break that down a little bit more later. But if you want some extra detail on your key spaces and table, that's where describe comes into play. It's really up to you, but I find the schema viewer is really nice from that standpoint. Oh, and I almost missed the history. So the history is nice. If you do have a case where, let's say that you had work you did in a notebook and you did something and you're like, oh my God, that's terrible, I don't want to do that, you can just go back, right? The notebook will, the history will allow you to go back. Alrighty. All right, moving on. Scroll down, banner operations. Right, and we will talk about the schema a little bit more. Okay, with that, at this point, if you want to feel like a Studio Jedi, there we go. We can all do this together. I don't have a hood. I should have put a hood on. I'm sorry. Yeah, and let's see. That's right. And I saw some folks that say no schema is shown for me in the viewer. If you see that empty box, just refresh. Yeah, just refresh. And then when you go to schema, you pick the drop down, say killer video, and you should see. Now, right now we don't have any tables. We didn't create any. We're going to get there in the next exercise, but you should at least see something just like that. I see which cloud service is this ASTRA right now. AWS. I want to say GCP as well. For those of you who are my helpers, if you have any other answers you want to add to that, but AWS and GCP for now. Okay, can I see some thumbs up for folks that have gotten through the notebook with me? Oh, haha. Oh, which GitHub repo? Oh, I thought someone was gonna talk about clone. That's an old joke. I'm gonna skip that here. I'm sorry. Once we get the thumbs up, wonderful. I see the thumbs up. I did see a question about the GitHub repo. I will drop that here in a moment. Once the thumbs stop. Okay, wonderful. Good. I see lots of thumbs up. That's great. All right, and here is the GitHub repo. I just dropped it in there. If you want to pop that real quick, if you missed it from before, I know we still have some thumbs up going. Just let us know if you miss it, and we'll put it back in there. Great. Wonderful. Okay, so we're going to move on, and we're going to go into the data modeling section. So like I said, this is probably one of the most important sections because this is the part where, if you get your data model right in Cassandra, you're going to have a wonderful time, right? It's like that for any database, really. Okay, so the general structure, right? If we look at how data modeling and the representation of data in Cassandra, we're going to have a key space. A key space, if you compare that to a relational database, is going to be equivalent to like a database or a schema, right? And our key space essentially is not only where we set our replication, but it's the container that holds all of our tables, right? And our tables in Cassandra have rows and columns, just like a relational table would, right? Logically, it doesn't look any different. Where the difference comes in is in something called a partition, right? So in Cassandra, the partition is the basic unit of access. When I showed you that graphic earlier with data being distributed around, and I said we're going to get to that partition key, this is that part. This is what we're talking about. So each in my tables for the various data that I have, I'm going to have partitions, and those will be defined by a partition key. So again, I have the key space that contains all my tables. My tables have rows and columns, and then each of those will contain partitions. So here's a more concrete example of what those partitions might look like. So here I have a case where I have some users that are organized by city, right? And you can see that I have users key space, and then within that users key space, I have a table users by city. Now, something to note by convention is when I say by city, I'm going to say I'm going to partition by city. So users partitioned by city. So notice that in my table, I have a city column. These are actually going to be my partitions in this case. I'm defining city as my partition. And then here are my rows. So each of my partitions can have a set of rows. And there's my partition key. So the partition is going to be set on the city field, and my partition keys are those values. So Phoenix and Seattle are my partition key values here. Now we have something called a clustering column. I'm not going to get into too much detail right now about that, but clustering columns are used for ordering and uniqueness. So what I want you to notice is this. Take a look at Phoenix, my Phoenix partition. Notice that both last name and first name are clustering columns. That means that in a text field, it's going to be naturally ordered alphabetically. So if you notice the last names, notice HLS, right? Same thing with Seattle, FJAC, JAS, right? They're naturally ordered alphabetically. Where this is important is when you want to denote an order in your data in Cassandra, you use a clustering column. What it does then is when you write data, it's actually going to pre-order the data. It's actually going to do it on the right path when the data is in memory at its fastest, right? And then when it actually flushes out to disk, it's going to flush out in that order. Why this is nice. So in a relational database, and by the way, this isn't me nitpicking on relational databases, it's just kind of illustrating some of the differences between them and where Cassandra has some interesting benefits. So in a relational database, where do I pay the cost for my ordering? I pay it on the read. I pay it in my select statement when I put my order by clause on there, right? Now, that is ultimately flexible. I can order on whatever I want, but at some point, I'm going to pay for that in the latency in performance. In Cassandra, with the way that data is actually stored on disk, it's stored in that order format, again, on the right. So when I read it later, I get it back pre-baked. It's essentially like I'm pre-optimizing the query and storing it on disk in that way. So this is something that a clustering column will do for us. So any other columns that are not my partition key or my clustering columns are then going to be what are my data columns. These are just the extraneous information that I have, right? And this then comprises a row. So looking back at this, I've got, again, partitions Phoenix and Seattle. Each of these happen to have a set of 3 rows. I have some clustering columns where my data is going to be ordered, and then I have whatever data columns that support those particular rows. Now again, those tables are tables, they hold many partitions. So if we go back to our users by city table, I have, as we just saw, the Phoenix partition, I have a Seattle partition, I have a Charlotte partition, so on and so forth. Now logically, if I did a select star from this table, select star from users by city, I would get all of that data. It would look just like it does from the relational standpoint. Here's the difference though. Those partitions are what are actually being stored around my database. So if I did in fact do a select star, Yes, logically, it might look like it does in the relational database, but from a physical standpoint, it's actually pulling that data from different nodes all at once and putting it together. So when I create, I mentioned a key space, right? That key space is going to be the container. So it's not only container of tables, but it denotes my replication factor. I alluded to this before. So this is actually very subtle and very awesome. So now in ASTRA, by the way, our key space was created for us. When you create your database in ASTRA, it automatically creates a key space for you. So you don't have to worry about this part. But if you're doing this on your own in your own Cassandra databases, you're going to need to know this, right? Creating key space is very easy. It's just create key space, the name of the key space, and then you set your replication strategy. So this command alone is responsible for that automatic replication that I was talking about. You don't need to do anything else. The second you do this, and you'll notice there's some other factors in here, like my replication factor. The second I do this, I will automatically be replicating my data on 3 replicas in data center 1. And if I wanted to add more data centers in there, I can do that after the fact. I can do that at any time. I can change this stuff on the fly, and that replication will automatically be changed and follow suit. It's really powerful that such a simple command does this, right? Something else I want to point out. Notice that replication strategy of network topology strategy. So by default, you will find when you are playing around with your own Cassandra instances and such, the default replication strategy will be simple strategy. Now, if I am dealing with a single data center, or if I'm in like a toy database or something like that, that's fine. But the moment you move to any production quality type database, or you're going to have multiple data centers or whatever, and even if you think, well, wait, I only have one now, use network topology strategy. Why? Because later on, if I add on data centers, I don't need to do anything, right? That's kind of a big deal there. If you use simple strategy, the default, in a multi-data center production scenario, it's not going to work quite the way you expect. So you want to use network topology strategy. That is the standard. And again, notice my replication factor. I'm telling it how many replicas I want right there. Now, to create a table, for those of you who are familiar with doing this in SQL or relational, this should look very familiar. So I'm going to say create table, my key space dot my table name. So defining the table name, I'll have a set of columns and their field types. Now, this example has all text. Obviously, Cassandra supports a lot more than just text. It pretty much any of the data types you could imagine that would come from the relational world, it's a huge list, are supported here. Really, what I want to point out is the difference in the primary key. So just like a relational database, we do have a primary key, but in our primary key in Cassandra, the first value is always your partition key. Again, this is the base unit of access. It is also required. You cannot create a table without a partition key, right? And then anything else after that is a clustering column. Something else I want to point out. See the parens here? Now those are optional. However, if you have a composite key, we're not doing that right now, but if I had multiple columns that were set in my partition, I would need them. But it's just a good idea to just use it, right? If you get used to using it, everybody knows that's exactly the partition key. There's no question, right? But if you don't use them, the first value is always your partition key. And then again, anything else that comes after it are your clustering columns. Okay, so with that, let's take that information. Let's go ahead and go into exercise 3. I'm going to go ahead and put this in here. Okay, I just dropped it into the Discord. By the way, notice at the end of those exercises, when I drop those into the chat, you notice there's a link at the very end. That link is the notebook file that you need. Again, you could do it that way. You could pull it that way, or you can just use the zip file here. It will be number 3, working with SQL. This is where, when we go back to Studio, we'll go back to the hamburger menu, go to Notebooks, and I'm just going to drag and drop the file in. So working with SQL, drop it, boom. And then you should get to something that looks like this. Oh, I saw a new emoji. What is this one? Oh, a face with 3 hearts. It's really sweet. Oh, that was Cedric. That's funny. All right, I see some thumbs up and everything. Right, so we're going to be in exercise 3, working with SQL. You should see something that looks like this. And we're going to run, remember that first cell? I want to really point this out. You're going to get here, you're going to run the first cell. You should see it start to processing. Now, this, by the way, I'm going to open this one up. This one, you can see where all the data model comes in here, right? That's what we're doing in these cells. So make sure to run this. If you scroll down and you're noticing you're getting weird errors and stuff, you may not have run this. Just make sure you run this part first. And again, if you were to do something, you don't have to worry about breaking stuff. You could do whatever you want here, and you can just rerun this as many times as you want. They're self-contained. It'll run. Once you've run that. You should see the success over here, and then you are ready to move on. At this point, I'm going to leave you guys to it. I'm going to give you 10 minutes for this and let you guys work through these. So let me go ahead and set. Can I set 11? Yeah, I can. I'm going to set 11 just to get a minute warm up for everybody. And I'll let you guys work through these on your own. Wonderful. I'm seeing thumbs up. Excellent. Awesome. Yeah, thanks, Ormed. Yeah, and Anil, I see that you downloaded the Git repo. Wonderful. You should just be able to drag and drop that Studio 3 tar if you downloaded it. Or working with CQL tar, just drag and drop that. Let's see, under the exercise folder, go to notebooks. Good point. Thank you for pointing that out. Yes. So there are. You'll see that we have some. We separate between the exercises, where we start in the beginning, and then the notebooks for some exercises. Sorry if that was confusing. So yeah, if you're open up notebooks, and you'll see the rest of the files that you need. And in case, if I don't know if everyone heard me. Okay, you got it. Great. I'll stop typing that then. Oh, thanks, Cedric. Let's see. I see no. I would say I'm looking at Pradeep there. A no viable alternative. Yes, yeah. It looks like the syntax might just be off. Oh, yeah. You guys just you. I forgot to tell you something, but that's okay. If you want, now here's something that I'm gonna tell you about, but I kind of want you to struggle. In each of the cells where there is something to do, some exercise, you'll notice that there is an ability. We put these special links in here if you want a hint. Okay, I would encourage you not to use them. I would encourage you to struggle. However, if you do need the hint, they are there. So if you scroll down through these as you're reading them and going through, you'll see there's the solutions. We do provide you the solutions in each of the cases. Again, try to struggle, but they're there if you need them. Guys see me laughing at myself here. if you're, Gwentology, if you're seeing a null pointer exception, I wonder. Let me see. If I do this, if I were to switch this to a markdown, would you get that? No. Okay, and maybe it's not that one. I know sometimes if you're in the wrong language, it might not do exactly what you expect. So that may not be that one. Oh, I see. Let's do it. Oh, look at that. Yeah, that's interesting. Okay. Yeah, it's something we can point out. Nice find, guys. Ah, that's fun. And for those of you who have just come on, if you happen to come on late or something like that, and you're wondering, like, hey, what do I do or something? If you take a look at the bottom of the video, you will see a link there to the Discord. Go to the chat. We're currently in exercise 3, but as we continue on, you'll be able to follow along. Oh, thanks for that information on Edge. Yeah, I think Edge is okay. I think it's just IE in particular. Is it ad name cord? That's a cool name. Oh. Oh, it looks like yeah, it looks like for some reason something happened with the sessions, guys. Just you should be able to go and log back in. I'm gonna attempt that myself. I'm seeing some messages come through. Okay. Oops, no, not that one. Yeah. Yeah, see, okay, so I do see I do see some funny comments is what I see. Yeah, okay, so let's do this, guys. It seems like we are having a fun little hiccup, so we'll go ahead and back channel what's going on there. Why don't we, for the moment, let's stop my timer. Let's go ahead and move on for a second, and we'll see if we can't get that handled. Oh, did it come back now? All right, let's try one more time. If not, we'll move on. Oh, I need to refocus. Okay, yeah, let's just go ahead and move on for now, and we will get someone to take a look at that. Alrighty. So, like I said, I'm going to go ahead. Yeah, isn't that great? Yes, love it when stuff breaks. Yeah, nothing like doing this live, right? You know we're doing it for real when it does that. That's for sure. Yeah, I'm loving these comments. We did it stress test. Okay, all right. So we like that. I'm gonna go ahead. Okay, yeah, we're gonna move on for now, and we're gonna let them do their thing. So, okay, so from a relational standpoint, this next section here is really going to get into some of the meat of what happens or what's different with Cassandra from the relational and SQL way of doing things, right? So if you look at data modeling in the relational sense, what do? Right? You start with a set of data. Then you apply your normal forms and stuff and model your data, right? Maybe it's an architect or a DBA, or even sometimes developers might do this. And you go through and you get your table in this in like third normal form, or something, or fifth normal form, depending on what you're doing, whatever. But you end up with an ERD and a structure that you can use that then later on, from the application development standpoint, when we as developers go to ask the database queries from our application, what do? Well, you go and you look at the ERD, right? You look at the ERD and you go, okay, well, I've got this table that has this information, this table, they have a join table here. I'm going to figure out my query and I'm going to put it together after. So you start with your data, you model the data to your normal forms, and then from the application development perspective, you then reference that model to create your queries and everything. In Cassandra, we literally flip this on its head. I want to pause at that for a moment. So we flip it. What does this mean? So in Cassandra, you're going to actually start with your application. You're going to start with the application workflows. You're going to start with the query access patterns that your application already has. You're going to use that to generate your data model, and then you apply your data. Now, for some folks, they're thinking, how exactly am I supposed to do that? Or my favorite question always is, wait a minute, does this mean that I need to know my queries up front? And I'm going to say yes. And then you're going to be like, how is that possible? I guarantee you, at the moment you even started to draw a UI out on a napkin somewhere, you have already started to define your application workflows and your query access patterns. And we're going to go through that process, right? So this is the difference. You're going to start as the application developer. You're going to use those workflows in your application to generate your data model and then apply the data. Let's take a look. What does this look like? So when you design a data model in Cassandra, the first thing you're going to start with is actually the same thing that you would start with in a relational database, your entities and relationships, right? You're going to conceptually model your data. From there, you're going to use your application workflow to generate your queries. This is actually a really neat point or part of how your application workflows, if you hadn't thought about it like this before, and then all of a sudden you start doing it this way, it's like, oh, wow, I didn't realize that information was in there. It ends up becoming this really cool process. And then from there, once you've used these two things to generate your entities and relationships and then your queries, you actually can step through the rest of all of the pieces that you need to actually generate your actual tables. Okay, so let's look at an example. Now, this example, this data model actually comes from one of our reference apps. So one of the things the Advocate team does is we build reference apps. One of them is called Killer Video. That part isn't as important, but what is it's like YouTube Lite, right? So in it, you have things like videos and users and comments and all sorts of things. So this is an entity relationship between users and videos, right? And what we're seeing here is that there is a relationship on comments. So in Killer Video, users can create comments on videos, and at videos, I can view the comments from users. So you see this relationship, right? This is no different from what I might do in the relational sense. This part is the same. But I can use this now to then start to generate what are going to be my requests, my application workflow, right? So, okay, I really have two paths here. I have users and comments, and then videos and their comments. So in request one, this R1 up here, what I'm saying, this is essentially a pseudo query, right? I'm saying I'm going to find the comments that are related to some target video using its identifier. So if I go to a video in the app, then probably so with my video ID, I want to find all the comments for that video. Then in request two, I want to find the comments related to a target user using its identifier. So again, in my app, I probably go to the user profile or something like that, and I want to see all the comments for that user. And at that point in my app, I have a unique identifier, probably some user ID for my user. And then request 3 is just like your basic CRUD operations, your create, read, update, and delete stuff, that kind of the basic types of operations you need for any database. Okay, so then from those requests, looking at my application workflows, how do I map those to my queries and tables? So if you take a look at the pseudo queries here, I misspoke when I said that a moment ago, I meant that here, you'll see query 1, find comments for a video with a known ID, right? So this is me literally just taking that request. I'm finding comments related to a target video with some identifier. So I'm going to say, okay, my query, a pseudo query might look like find comments for a video with an ID. So, select comments from video with video ID equals, right? But that generally is going to map into something comments by video. And if you remember before when I said the convention by and my key. So this table name is comments by video. That's it. Very simple. And the second query here, query 2, it's the same kind of pattern, right? I want to find comments posted for a user by a known ID. So my table, comments by user, I'm going to key by user. And with that, I literally just took very quickly, right? I realize it takes a second to kind of grok like that flow, but once you've defined the application workflow and you use that to like generate a pseudo query, you can then start to tease out what do my tables actually look like. So in the case of comments by user, well, I want the comments by user. We already said by user, that's going to be my key. So my user ID is my key. Now, this notation that we're looking at, we're not going to go into a lot of detail, but it's called a Chebutko diagram. The K means partition key. C's mean clustering columns, right? That's all we're saying. This is something that some of us use in Cassandra when we're doing our data modeling. So I want comments by user. So if you think about what comments might look like, well, one, a user by user, I want the user ID. Then chances are if I'm going to display comments, I want the date because I want to put them in an ordered form based on date. I'm going to need some reference to the comment itself, the ID for it. Remember, there is a linkage between the comment that the user made in a video, so I want to bring in that video ID, and then also the comment itself. And in the case of comments by video, same deal. By video, video ID is my key, my partition key. Again, comments, creation date, I want the date, the comment ID, the reference to the actual comment. Now I want that linkage back to the user, so I provide my user ID and then the actual comment. Now something to point out, this is the logical data model. When I am then, say, going from logical to physical, I may perform an optimization step if it's needed, right? So I want you to note, I go to the physical data model. Look what happened. I reduced a column. Here I had, in each case, right? I had 5 columns and now I have 4. What happened? Notice this comment ID, right? Notice now it is time UUID. So there is a field type in Cassandra that will allow me to combine a timestamp along with a UUID, right? That's the time UUID. So if I go back, notice that creation date and comment ID, well, creation date's my timestamp, comment ID would have been my UUID in the Cassandra case. So I just consolidated it. Could you have implemented these logical tables as your physical data model? Totally. Just going through this step to this is just an optimization, right? So you notice it looks very much similar. And then from here, that's it. I've generated what my data model is going to look like. I literally can create my create table commands. You'll notice here are the fields that we used. This time I have some other examples like UUID, time UID, text. And then remember, user ID is my key. So I'm going to set that as my partition key. Now, something I didn't really talk about in this case is that I do want to order by my comment ID or my timestamp, right? That way, when I do the select query from my table, I will automatically get the data in its ordered format, in its time-based ordered format. I don't have to do anything else there. I don't have to pay the cost anywhere else. That's kind of an implementation detail in this particular case. I just wanted to point it out. And then from there, I've generated my tables. Now in Cassandra, we use generally a query per table design. So there are no joins in Cassandra. So with that, I have literally, in this case, I have generated through the application workflow, I had 2 flows, 2 pseudo queries. I generated 2 tables, and I have 1 query per. So if I want to get the data from for all the comments for a particular user, I'm just going to say select star from my comments by user table where that user ID is some UUID. Same thing for the comments by video. It's actually that simple, right? It actually breaks it down to being very simple. So each one of your tables is going to contain the information that you need to answer that particular query, is what it comes down to. Okay, so with that, let's see. Have we gotten past, before we go to exercise 4, maybe someone can tell me, how are we doing on the, did we get past our little storm here? Let's find out what happens. Oh, I hope so. Yay. Oh, much better. All right, good. All right, good. All right, let's go to my database. So if, for those of you who, I realize you probably got stuck in exercise 3. Well, this is, one of the things I was talking about before that actually works out really well is the fact that these databases are going to stay up indefinitely. You can come back to them anytime. So what I'd like to do, I think for now, just in semblance of time, to make sure that we have enough time to get through everything, let's go ahead and move on to 4. And then later on, you guys can follow up and just go into exercise 3 on your own. So I'm going to go ahead and drop exercise 4. I appreciate you guys, bear with us through that little hiccup there. Okay, there's exercise 4. Again, for those of you who downloaded the zip, you can see I have it here. I'm just going to drag and drop that in. And I just dropped the link in the Discord chat as well. And don't forget, if you do have questions, on the things I'm talking about and questions, clarification, please ask in the questions room. I'm not trying to chide anybody, but that way it keeps the main room from getting inundated with too many of those. All right, so again, here we're in workshop or notebook 4. Again, don't forget you have this first, what looks like to be a blank cell where all of your data model is. Make sure to go ahead and run that. And we'll give you guys 15 minutes for that one. Actually, I'll do 16 and give you a minute for warm up. There we go. I see lots of wonderful questions in here, by the way. Keep them coming, guys. Yes, Lectura, I see your question here. Yes, you are correct that if a new query that is added, a new table is added. Yeah. Matter of fact, something I want to point out, that's a very good question. I'm glad you asked it. In Cassandra makes a trade-off, and I know you guys are trying to work on your notebook, so I'm sorry if I'm talking in your ear, but Cassandra makes a trade-off between using up more disk space and the performance it gets at scale. So it is a denormalized data model. So yes, as you rightly inferred, right, that you will have cases where in, say, multiple tables, you might actually be storing the same type of data over and over and over in different tables, right? But disk, as far as the commodities go, between memory, processor, and all sorts of things, disk is by far the cheapest, right? So it makes a trade-off to use more disk space and use the speed there to then achieve very fast writes and very fast reads, because in a relational database, they are wonderful general purpose machines, but because of that, because of the way the data is stored, your read latency can be pretty high especially as you try to scale up and everything like that. So it's a trade-off, is what it is. So you are correct in that question. Yeah, Manny, I see their question. We have to update all tables for same data again. Um, right. If you have like data across tables, there is a mechanism I'm going to talk about later to synchronize across multiple denormalized tables. But if it is something that you want to ensure that across those tables that you do have the same information, yes, you will have to update them all. Yeah, and Alex is telling you about it right now. Yeah, we will show batches later today. Sorry if you hear me laugh randomly. I'm watching the chat here. I see some funny things happening. Okay, and by the way, and I'll mention this again in the end. For those of you who have messaged Jack on Discord, please message him with your full name. That way, yeah, it looks like he's asking that you message with your full name, so he can better track down who you are. Yes, yes, you are supposed to create the schema. So if you take a look at the notebook at the very top, remember there's that empty cell, it looks like. You want to run this. This has all of your schema in it. So later on, if you're getting weird errors that are like this doesn't exist, this doesn't exist, you probably didn't run this cell. Matter of fact, another way to check is if you open up the schema viewer, you should see a whole set of tables and stuff in here that are related to what's going on here. So again, if you don't see that, you may not have run the cell. Just go ahead and run it. For those of you who are seeing the query right now where are using rating, yes, thank you for posting it, Manny. Here you go. So I'm gonna go ahead and put this on the screen. Check this out. Read on. I'll explain it after because this is something I want to talk about. But if you read on to the next cells, it should explain what is going on here. That is on purpose. Yeah, we were being a little tricky there with that. We're using it to illustrate something about allow filtering. see. Yeah, I see a question here: is Studio an alternative for Dev Center? They're really kind of meant for different things. I believe Dev Center at this point has been it's I want maintenance mode. If not, I think Mark, you're on. Maybe you can answer that one. Um, Dev Center was definitely more of a tool that, say, an administrator might use, something similar to other DBA-like tools. A Studio is really more. It's a whole different feel with being a notebook style interface. So they are different tools. So yeah, it's definitely an alternative. But I would actually say that they're really not one and the same. They're two different tools for different things. Yeah, there's a question here, Manny, how to make sure the ACID transactions. So in Cassandra, there are no ACID transactions. There is something I'm going to talk about later called a lightweight transaction that is probably the most ACID-like in Cassandra. So yeah, there is no ACID compliance quite like you would expect from a relational database. Got about a minute left, and then we're going to go ahead and go on. All right, here, I'm going to go ahead and stop this. Let me do something real fast. This. Okay. All right. Okay. All right. Moving on. And again, by the way, if you didn't get through everything, that's totally fine. Again, these databases are going to stay up indefinitely, so you can follow. And by the way, we're always here in Discord too. So if you guys have questions or anything as you're doing this stuff on your own, come ask us. We're here. So yeah, like no worries. Okay, so like I said, there are a whole set of different primitive types that you could. You guys hear me? Like a thumbs up if you can hear me. I have no idea why, of all days, these batteries usually last for days, and they both keep just dying on me. I don't know what's going on. Anyway, as long as you can hear me, that's wonderful. Okay, like I was saying, so sometimes though, you need to do things that go beyond what the basic primitive types will give you. That's one area where collections come into play. So there are three different types of collections in Cassandra. We have sets, lists, and maps. Now what's really cool for all of us developers out there, you're probably very familiar with these types of objects, and they act very similar to what you'd expect in Cassandra. So if you're already familiar with what a set does and a list does in a map, you're already going to be familiar with it in Cassandra. So it's not really different. So sets are going to be unordered things, but you cannot repeat an item. So if I create a set of something, I can only have one instance of whatever those things are. I can repeat items in an ordered list. Maps with my key value pairs, I can't repeat a key, right? So we'll go over some of this stuff. Again, that's no different from what you might expect in code. So what does this stuff actually look like? All right, let's start with a set. So you can see in the example when I'm creating my videos table, I have a set of columns and their field types, but boom, if I want to create a set, this is it. The nomenclature is really easy. The syntax is really easy. I just say, okay, for tags, I want to have a set of text. And that means that for my tags field, my tags column, I'm actually going to have a set of multiple tags that can exist. And what's even, I think, cooler, again, the way that a set's going to work is because I cannot repeat values. Even if I had a case where I'm adding values in there and I had to repeat, the set by its nature will not allow me to repeat those. So I'm going to be sure that it's just going to be unique items in there. So how do I work with them? You're going to find that as we go through these types, they all look very similar. Again, from a code standpoint, this should also look pretty familiar to you as well. So you're gonna, yeah, like I said, it's a normal pattern that we're gonna use for all these different collection types. It's actually really easy, and the syntax is pretty straightforward. So here we're going to insert some data into a table. Now in this case, we're using sets. My tags is a set. So I'm going to insert into my videos table with some ID and then whatever tags. Notice the braces, and so my tags are going to be side splitter and short. So I insert that. Now for this particular ID, I have a set of side splitter and short. Now let's say I want to replace the entire set. Well, notice what I'm doing. I'm going to update, again, that same table, the same ID, right? The same ID as before. That's my partition key. But now when I say update, I'm going to set my tags equal to, and my curly braces, dark and sad. So if I were to perform a select query right now at this middle one, I would get dark and sad. Side splitter and short would have been completely replaced. But if I just want to add to the set, now I can go ahead and just literally add it on. I can just say, give me update set tags equals tags plus whatever the value. So at this point, if I were to then select from this table with that ID, I would see tags equal dark, sad, and enthralling, right? So it's, again, that should look pretty familiar to anyone who's doing code or who's developed in code. Now with a list, similar kind of deal. In this particular case, I'm going to say I want to define actors as a list of whatever the field type is. So in this case, I want an alphabetical list of actors. How do I work with that? So the only real difference here, everything is going to be the same, right? Except for notice instead of braces, I'm using brackets, right? That looks just like a list, an array. So I'm setting Adams, Baker, and Cox for this particular ID. Then if I want to replace the entire list, what do I do, right? Just like before, I'm going to update, and I'm going to set that actors field equal to, again, whatever's in the brackets. So at this point, if I were to then select from that table with this ID, I would see Arthur and Beverly. I would have totally replaced Adams, Baker, and Cox. And then if I want to append to it, I think you see where I'm going here. I'm going to update. I'm going to set actors equals to actors plus whatever the value is, again, in my brackets. One other thing you can do with lists that you can't do with the other types is you can actually get access to a specific element. So notice here that if I wanted to update a value in a particular element, I can reference that element directly. Now, part of how Cassandra maintains its performance at scale is it does not perform a read before write, right? It literally appends data on, and the last write wins, right? It actually allows us to scale very high. There are some operations, though, where you need to perform a comparison before you do something. This is one of those. So if you do use know that you are incurring a read before write, which does imply a performance penalty, right? So just something to keep in mind. It's okay to do, but you definitely want to keep that in mind as far as the performance standpoint. Okay, then with a map, right? So in this case, I'm going to have a map of phone numbers. Notice here, this is going to be key value, and in this case, both of those fields are going to be text. How do I work with a map? This should look very familiar yet again. I'm going to insert data into my users table by, with some ID and then whatever the map is going to be. So notice the difference here. I'm back to my braces, but notice key value, key colon value, key colon value. So I've got keys of cell, home, and business, and then the values are the numbers. By the way, anybody recognize 8675309? Anyone recognize that number? Put it in the chat if you do. Okay, so that's when I am inserting the initial map. What happens if I want to replace it? This is going to look familiar. I'm going to update. I'm going to set phone numbers equal to the exact value in my braces. Again, now I'm replacing what I had before. So if I did my select statement at this point, my phone numbers will show me cell and office. And then last, if I want to append on to that or add to my map, actually, I will update, set my phone numbers equal to phone numbers plus whatever I'm adding on. So at this point, if I were to select, what would I see? I would see cell, office, and desk. Okay, so another type, a more complex type, is called a UDT, right? User-defined type. So these are very useful for certain cases where you know that not only am I going to have a complex type, like address is a really good example, right? Address is usually not comprised of just one field. In this case, we have street, city, and state. Could have plenty more in the case of an address. But I also might want to use address amongst multiple tables across my key space. So I can define a user-defined type that will actually be defined at the key space level. And then I can very easily reference that later as another type. User-defined type, I just reference it like any type. So in my users table, when I say, okay, location wants to be an address, I now just define it as an address type, and it will then have these particular parameters. How do we work with this? It's really similar to what we just saw a second ago, right? So again, I'm going to have my insert statement into my table by some ID, and now I'm going to pass in this location. And here's my braces. And notice here were my field values, street, city, state. Notice the references, street, city, state. If I want to replace the whole thing, I'm going to update. Again, obviously, if you notice all these updates, right, they're going against the same exact table in the same key. That's a given there. I'm going to say set location equals to whatever the value is. So if I were to then select at this point, I would see 234 Elm, New York City, New York. And then now this is actually something that's pretty cool about UDTs. You can actually get access to the individual fields by using the dot notation. So notice the location dot city. So I could actually just replace one particular field there. And you can actually do the same thing in the select statement. So I could, instead of having to select the whole thing, I could just say select location.city from my table at a particular key. Okay, so counters. There are counters in Cassandra. The first thing I want you to say, or want to say about them though, is they are not for exact values. They're more for imprecise views. So let's say you've got a YouTube channel and you've got a video out there or something like that. This is really good for a case if you want to say count the number of likes or something you have, right? Is it really important that you know that the counter is at 1,286,364 or 65, right? You can have a little bit of give there, and that's perfectly fine, and that's good for a counter, right? And counters, the way that you work with them, you increment them, you decrement them. You can't insert directly here. I'm going to show you that in a second. And when you create a counter, it's assumed the very first value is 0. That is where you are starting. So a couple things about counters, though. They can't be part of your primary key. I'm going to show you an example of this in a moment. And you cannot mix them with other types, period. So if you have a table that has a primary key, which is allowed, and then a counter, you should not have any other types in that table other than a counter, right? And like I said, you cannot insert them directly. You have to increment or decrement. So let's take a look at what this looks like. So here's a table, video playback stats, where I'm implementing a counter. Notice I do in fact have my primary key though, so that's one field I can have, but then I have a counter for views. If I wanted to add any other fields to this table, they would also need to be a counter type. I could not have other types in here. And this is what I mean by you have to increment or decrement. You cannot insert into these, right? So if I have a counter, then what I can do is I can update and I can say, okay, I'm going to set views equal to views plus 1. I now incremented by 1. Or if I want to decrement it, I will set views equal to views minus 1. Can I increment or decrement by larger values like 50 or something? Yeah, I can, right? So know that you do have some play there, but you have to use this mechanism. You cannot insert directly into them. Okay, so with that, let's go to exercise 5. I'm going to put that down into the chat. There it is. And go back to my hamburger, notebooks, go to my files, advanced data type, bring it in. And again, do not forget this cell here. The first one, it looks like it's hidden. It looks blank. Run that. Definitely want to run that because that is your data model, and you'll get errors later on if you do not. All right, and we will go ahead and give 15 for this. Good. I see some thumbs up and rockets. Thank you guys. I appreciate you doing that. Let me know you're seeing it. Oh, something I want to. I'm looking through the questions, and something I kind of forgot to mention when I was talking about the collections, especially in map. Try to prevent yourself from making a database within in a database, right? Cassandra will allow you, if you made a map of a map of a map, it'll let you do it. That's not a good practice. That is an anti-pattern and something that will cause you trouble in the future. So try to ensure that when you do use them, that you are not, like I said, creating a database in a database, right? Use them for a single purpose. Yeah, Pranav, I see a good question from you. Isn't an insert essentially an update and upsert? You are absolutely correct. Yes, in Cassandra, they are essentially one and the same. Yeah, and I will talk about this at the end when I talk about the certifications again. all the materials that you guys need for those of you who are interested in taking the certification exams. When you get the voucher and you go to do it, right? In DataStax Academy will be the resources that you need. It's actually going to refer you to some of the DataStax Academy courses. And by the way, if you're not familiar with DataStax Academy, we haven't quite talked about it yet. It's totally free. You don't have to worry about any of that there. What we are doing in this workshop today will not be enough for you to pass that exam. So the resources that you need will be there. You'll see it where the exam's listed. You will actually see those. You can go take those courses. Once you've gotten through those, then you'll be in a good spot. And I will mention that again at the end. I double check on the map example. I thought we had a map example. Oh, okay. I saw a question come through about whether or not there was a map example, and I thought I had one in here. I guess we don't. Maybe we should add one in, honestly, because we have the other two. Yeah, and I don't have it in the bonus content. Yeah, it looks like maybe not. So that's a good point, and maybe something we'll add in. Oh, Sesha, for the video recommendation schema definition, what it looks like, if you're not able to find it, make sure at the top of your notebook that you run this cell, because all the stuff that you should need, video recommendations, it should all be in here. So if you haven't run that cell, then you're going to be running into trouble as you go down. Oh yeah, thank you, Cedric. There you go. That was a better answer. Okay. Oh, so you were able to run the other ones. Yeah, Sesha, that might be something to maybe add in a screenshot or something. I wonder if something's fat fingered or whatnot. By the way, for those of you who are trying to reach out to Jack and you're wondering how to contact him, if you take a look at the very right-hand side under the helpers in Discord, you'll see Jack Fryer. You can click on that and direct message him directly. And again, if you do direct message Jack in Discord, please provide your full name so he can actually track you down. All right, we have just under a minute, and then we'll continue on here soon. Alrighty. Whoops. Oh no, I got the alarm. There we go. Let's try to miss that. By the way, I'm seeing some wonderful questions come in, folks. I really appreciate that. Keep them coming. Got to keep all of our helpers busy, right? I bet they just love that I said that. All right, let's go ahead and move on. And again, if you did not get through everything, that's okay, because these databases are going to stick around, and like a lot of these do have bonus material and stuff that we don't expect that you can get through today, in the time that we have. So that's fun to kind of noodle on yourself. And again, if you always need to, you can always reach out to us if you have questions. Okay, so this is actually going to get into some questions that I've seen come up, right? If whether or not there are ACID-like transactions or whatever can you do in Cassandra, and there is. It's called a lightweight transaction. So really, where these come into play is, in like race condition scenarios, or if there's a case where you need to ensure their insert or update operations are unique and that require a compare and set, a read before write. That's where a lightweight transaction comes into play. And I'm going to kind of break it down here for you in a moment. One thing to point out about these, though, right, is that Cassandra is built to work in this asynchronous nature, right? You're going to get the most throughput out of it, the most speed and performance out of it by treating your queries that way. When you use a lightweight transaction, because of the fact that you have to do this read before write and comparing and setting and stuff, there are performance implications. So you don't want to just use lightweight transactions for all of your operations or something like that. You're going to slow yourself down. So use them sparingly. And let's look at an example and kind of where this comes into play. So here's the type of problem that a lightweight transaction might be really good at handling. Let's say that I have two application instances, application instance A and B, and then I've got my Cassandra database. Well, application instance A is going to read record 1, and then application instance B reads that same record. Application instance A now makes a change to that record, but then application B also makes a change to that record right after it. Now, what happens when application instance A goes to read that record again? Its changes are gone, right? That, depending on the scenario, might be problematic for certain things. So if we look at this from actually looking at some CQL, right? Let's see what this looks like. So in this top case, I'm going to select from the user credentials table where email is my partition key newuser@gmail.com. Now, right now, I don't have anything in there, right? So it's empty. Now I insert some data, and notice that I insert at newuser@gmail.com, password A, right? Password underscore A. But notice I'm using this if not exists. This is how you trigger an LWT, right? So when you want to use a lightweight transaction, you'll use if not exists in the insert or if in the update. You'll see examples of both, and that will say, okay, I'm going to do this compare and set. So it's going to compare and see whether or not this stuff exists or not before it writes it. And guess what? In this case, there was no data, so it's going to come back with applied, and whoops, my bad, applied true. Now, something I want to point out about this. If you're just doing CQL, the CQL shell or Studio, you'll get this applied true. If you're in code, you will actually get this back as a Boolean that then you can reference. So it's nice because if you're specifically using a lightweight I think it's was applied, I want to say, if you're using that, then you'll have direct access to that so you can test for it directly, right? Okay. Now, after I've applied this, because there were no values that were in my table, I now have a new row. So new user at gmail.com with password A. So now I've got this data. It's already in the table. Notice again password A. Now what happens if I want to go ahead and insert some data? Notice the same key. Now, before I move on, and yes, in this query I am using if not exists. Pretend for a moment, though, that I wasn't. What might happen? So Cassandra, in this case, is just going to upsert. Right? If I did not have an if not exist, if I did not use a lightweight transaction and I perform this insert statement right over this, it's just going to upsert. Last write wins. It's got that same key. My password would be updated. So in this case, I clearly don't want to do that, right? So this is where I use the lightweight transaction. I say if not exists, and notice that password value. But this time, because I already have the previous value, it's going to actually return false. It's going to say, no, I cannot do that because the password is not the value that it expected. So if I were to then select the data out, I would actually see it is the previous value. So what's cool here is if I'm trying to apply a lightweight transaction and I get this Boolean, this applied false, it's actually going to return me back the current state that I can then use to try to reapply my lightweight transaction. And you can see, again, if I select it then I still have password A. So I'm really trying to get this password updated to password XYZ, but the lightweight transaction in this case protected me from being able to update in like a race condition like scenario and just kind of like completely override somebody else's updates. So now what I can do in this case is I can use an update with a lightweight transaction. So this time I want to say, okay, let's go ahead and set the password to password XYZ, where the email is that key that we use, and user@gmail.com, and if password is password A. Now I am bringing the state into play and saying, okay, this is the current state that I believe it's in, and if it's in the state password A, go ahead and update it to password XYZ. So notice, again, I just added the if password, and that's my condition. In this case, that works, right? Because the current state of the password was password A. Now I use the lightweight transaction to ensure that I'm in the right state. I get the applied true, and now it's applied. I also saw some other questions come through regarding batch. So something to be very clear about with Cassandra is that batches in Cassandra are not the same thing as batches in a relational database, right? They're just not the same. Where in a batch in a relational database, I might use that to say batch up and import like a ton of data all at once. That is not what a batch mechanism in Cassandra is for, right? Batches are for those cases where I have multiple denormalized tables. This question came up by a couple folks earlier in the Discord when we were talking about the data model part. If I have multiple denormalized tables that all share a key or share like data, I can use the batch to try to keep them in sync, right? So that is a clear distinction between how you do things in the relational world. So in this case, I have 3 insert statements. In the case of the batch, what I'm actually saying is I'm going to apply all of these as a group, right? So if I'm inserting into one table, another table, yet another table, I'm saying either I'm applying it to all of them or I'm applying it to none, right? And this is how you use it. So I just say begin batch, I put my statements in here, apply batch. Something, by the way, I want to point out here. This is not transactions. These are not the same thing that I might do in a relational database, right? So I wouldn't expect to see an insert, then a select, and based off of that, then insert something else. That's not what these are for, right? Again, they are not the same as a relational batch. And are they atomic? No, right? These are essentially a stronger retry mechanism. That's really what we're doing when we're batching up. We're saying that when I put things in a batch, I want to keep certain data and certain tables, denormalized tables, in sync, and the system, when you use the batch, will retry and retry and retry essentially until all those operations are complete. It's just a stronger retry mechanism, but it is the way that if you did have a requirement to keep multiple denormalized tables in sync, right, that you could use a batch for it. Okay, so with that, we're going to go into this next exercise. Exercise 6. I will put this in here. There you go. And of course, I will do this with you guys. Go to my hamburger menu, to the notebooks, pull up my files. Exercise 6. Boom. And it should bring you right into, you should see exercise number 6, LWT in batches. And again, do not forget to run the cell, the empty cell. It looks like empty cell, but it's not empty. It's got all the stuff in there. Run that. Make sure you see this. Make sure you see the success before you continue on. Oh, is Twitch acting weird? I do see my stream on there, so I'll keep an eye on it. Thanks for letting me know. Oh. Uh-oh. Well, that's not good. All right, I'm seeing some messages about ASTRA and the server piece. Let's go ahead and see if we can't get someone on that. Okay. Oh, yeah, here. I'll give you the download for link exercise 6. There you go. Yeah, we do notice the ASTRA thing, and we're going to get that taken care of. Thanks, guys. I should mention this is the highest amount of people we've had doing one of these at the same time. So I wonder if we are running into some constraint there. It's good to know. This is a great stress test, honestly. All right, let's see. Okay, we'll give it a second. Obviously, with that, I mean, I'll reset the timer here once we get there, so you guys can have proper time. I wanna. But mine is still not back, so yeah. Hey, that's right. While we're waiting, someone just let me know of a question about allow filtering. I'm so glad that you brought that up because while we're waiting to see, to get this ASTRA thing back online, let's talk about allow filtering for a moment because no one can do their exercises anyway. So allow filtering is actually kind of funny because it is one of those areas where Cassandra will literally tell you about the anti-pattern not to use and tell you not to use it, but then give you the exact pattern you need to use it. So here's what I'm talking about. Some of you may have noticed in one of the exercises earlier that when you try to execute or perform a query against a column in your where clause that was not in that primary key or that partition key, like rating, I believe it was, you get this allow filtering thing. So in a relational database, let's pretend I have a table that has, say, like 5 columns in it, right? And I have my primary key is only on one of those columns. Well, in a relational database, in my where clause, I could say where any of those columns, right? I have no problem with doing that. It may not be the most efficient thing, depending on my index and stuff, but I can do that. The relational database will allow me to do that. Cassandra will not. And let's think about this for a moment. The analogy I like to use is like a pizza delivery one. Okay, remember your data in Cassandra is distributed around your nodes in your database, right? And that partition key, the partition key essentially is giving me the exact address to a particular piece of data, right? So when I am performing a query and I have the query with a partition key, then what I'm saying is, okay, pizza delivery guy, right? I put in an order and the pizza delivery guy is able to go, or girl, whoever it is able to go directly to that address and go knock on that door and deliver the pizza. But if I use a column that is not in my primary key or my partition key, then what I have to do is I actually have to scan through all of the data in all of my other nodes to find what I'm looking for. So that would be equivalent to, instead of just going directly to the address, then if I had a city of 1,000,000 people, I'd have to start knocking on all the doors. And, oh, is it your pizza? Is it your pizza? Is it your pizza? That's not going to be a very efficient operation, right? That's going to take some time. That's going to take some load. So what happens is it's funny that Cassandra will tell you, in a case where you're using a column in your where clause that is not in your key, it's actually saying, hey, you can't do that. Cassandra doesn't allow you to do that. But if you want to do that, go ahead and put allow filtering on. So funny enough, you could actually put allow filtering at the end of that query and it'll work. Now, here's the thing though, and this is where it'll get you. And this is why I'm going to say to you, do not use it flat out, right? Don't use it. In Cassandra, when you have small amounts of data, right, you could do allow filtering. It looks like it works fine. You'd be like, wow, this feels just like what I've been doing in relational databases. I'll just do this. That's great. It will not scale. Eventually, it will fall on its face. Why? Because you're going to scan. You have to scan through all those nodes to find that data. It is not how Cassandra is meant to work. That's why that partition is the basic unit of access, and use the partition of the where clause to go pull that data. So it is kind of funny that Cassandra will literally tell you the anti-pattern not to use. I'm here to tell you, don't use allow filtering. And matter of fact, I totally get, like when I first started with the Cassandra, coming from years and years in relational, it was comfortable. But then you really want to get used to the pattern of using your partition key to get your data. Once you get used to doing that, then you're in a good place. If you get too used to using allow filtering, what I really don't want you guys to end up with is a production app down the road that is brought to its knees because you used allow filtering. And we've seen that. We have definitely seen cases where people later on, I'm like, man, this Cassandra, it's supposed to be so fast. This thing sucks. It's so slow. Man, it crashed and stuff. And then you take a look and you see allow filtering on every single one of the queries in their production database. They just didn't know, right? So anyway, that's what I want you to avoid. Don't use it, and just ignore the fact that it's there. So, okay, are we back? Are we back? Let's see. Let's take a look. Ooh, yay! Well, kind of. I mean, it's at least spinning. I'm not going to say yay yet. Oops. I don't mean to go to Zoom. Just ignore what I'm doing there. There we go. I see some people are saying they're back. Maybe that's just not everybody yet. Yeah, Lexi, let's see, Leslie ZB. How do I say that? Les IZB? Lex ZB? Anyway, yes, exactly. With the allow filtering, you didn't know what you didn't know. Exactly. Yeah, that's what it comes down to. If you don't know better, you would never know that that's an issue. So yeah, that's why we like to tell people just don't use it. Yeah, I'm seeing the same thing, Sanjay. It's still not up. Okay. Yeah. Yeah, watch out with Zoom. Yeah, totally. I did, by the way, set all my security settings up on Zoom to ensure that I can't get Zoom jacked or whatever it's called. All right, let's see. All right, I'm doing a check with the team here to see what's going on from the ASTRA standpoint. Ormad, that's very funny. Our developers are so nice. We have all queries with allow filtering. Yeah. I feel like you're joking, but if you're not joking, I hope you, at least if you come away with nothing today, you come away with, you must go change that immediately. Yeah. Oh, I see all sorts of fun emojis there. Ouch, Cedric. Ouch. Oh my god, it's I'm not going to read all the stuff that is now showing up in the Discord chat. Okay. Yeah. Yeah, right. All right. I appreciate you guys bearing with us, by the way, with this. Funny enough, this is, out of all the times we've done this is the first time I've seen this particular thing happen with ASTRA, and this is by far the most people we've had. So I do wonder if we did something with all those folks being out at the same time. All right, and I am still working with the team in the back end. Again, I really appreciate your patience. Please bear with us for a moment. Oh, here we go. I got to log in again. All right, let's try it out. Let's see what happens. Nothing like it comes back and then like a million people go on all at the same time. Let's stress it right over. All right, we should. It looks like it's coming back. We should probably give it a moment. I'm assuming. Oh, Emilio, are there other like AWS troubles going on or something? Yeah, Jai, or if you get that error, the login process started from beginning, just refresh. All right, it looks like. Yeah, I agree, Sanjay. It does look like it's still a little stressed. Okay, I think at this point, I need to call it from this standpoint. Otherwise, I'm just gonna, have everybody kind of waiting around. The good thing about it is that, we've actually gotten through. Those were the set of exercises that we're going to do today anyway, and you guys can follow up with these later if and maybe what we can also do, if you guys want, for those who would really like to, separate from your own time, if you want to go back through some of this stuff together, we can do that. So I would say hit up Jack, let him know that you're interested in something like that, and we can do a follow-up piece. Yeah, for now, guys, I'm gonna move on from the studio or from the ASTRA piece because it looks like it is still stressing out. Yes, as far as the presentation, all of the stuff that I've presented today is actually in that GitHub repo. We will post it again. So you have all the materials, all the notebooks, everything that you have. The Astra will still be there and all that. So we'll get a line on what kind of happened today, but you guys should be able to do this stuff and follow up on your own, no problem. As a matter of fact, this is the very material from that standpoint. So other than today, oh, there we go. Cedric just dropped it down. There you go. Thank you, Cedric. He just popped it in there. So that is the presentation. So you can look at that on your own. So there are another set of resources that are available for you guys. So I did mention Academy earlier. This is actually where you'll do the certifications as well. Academy is free. You get to that at academy.datastacks.com. As a matter of fact, I have another link for you guys. I'm going to put that here. There you go. Yeah, you see some links I just dropped in there. So Academy has a whole set of course material and stuff. I'm actually going to show you some links for that, later on. So if you are looking to get into a lot deeper discussion, like what we have time for today and what we went through today, scratches the surface, right? So if you really want to get deep and you want to get all geeky and stuff, Academy is a really good place for you to go. There's courses in operations, administration, data modeling, if you want to graph all sorts of things. And again, it's all free, right? The whole thing is free. Then if you guys have questions that you want to follow up with, the Discord is one way to do it, but community.datastacks.com is really a good place to go because you will get a lot of the very developers and the stuff that the contributors for Cassandra are there, right? So you're going to get expert answers from folks. So I would say if you've got questions about Cassandra and you want to get more in-depth responses, go to the community. We are all over social media. I think at this point, a lot of you guys know that we're on Twitter and Twitch. Well, you're watching Twitch right now, but we are at datastacks.devs. And this is the course. So Cedric just dropped it in here. There is also a course online in Academy for this workshop right here. I'll make sure that you guys have that. There you go. So I just dropped it in. This is actually the same course that we did today, right? You can actually do this self-paced on your own in Academy, right? Again, it's all free. All the resources that you need, I believe, if I go here real quick, yes, all the resources that you need, right? You're going to find that for each one of the sections, I mean, you've already got the notebooks, right? But each one of the sections are here, the slides, all that stuff. It's going to bring you through everything that you need. There is a virtual machine if you want to use that for the self-paced folks. I am seeing messages that ASTRA is back, so let's take a look. Okay, wonderful. It looks like, and are you guys, everyone able to get back? Yes, Alex, I will review the whole certification thing at the end. Okay, great. How about this? We've got time. We actually have still, a little bit of time. Why don't we go back? Let's try it again. And I will just go back to where we were. Here we go. We're going to do exercise 6. So let's go to my database. I'll give you the whole new 15 minutes so you guys can get through that. I would rather see if we can get through it. And 6. And let's go ahead and reset our timer. Wonderful. I'm glad it came back. Yeah, we'll have to find out what happened with that today. And you should, you might, depending on how you got, if you were already kind of halfway down or something like that, go ahead and try to continue on. You should be fine. But if for some reason not, you can always rerun this piece and we'll give you time again. Yeah, again, I really appreciate everyone's patience with that. Yeah, Jay, by the way, we will send follow-up emails to you guys that have the resources in there as well. So that is something that we do as well. Let's see, Rohini, if you don't see all the notebooks in your Astra, all you need to do you can either, like if you're trying to do 6 that we're doing right now, you can just bring it back in, drag and drop it in. If you need me to drop it into the Discord, you let me know, and I will happily drop a link. Or are you saying there's something else going on, like they disappeared or something? I'm seeing some questions. Rohini, I wonder if you're a Windows user. So if one thing that, for whatever reason, I don't know why, but sometimes when people go directly to the link that is in the GitHub repo, like if you go to the notebook and you download it here, for some reason I've seen some people on Windows that come back with a like the file is corrupted error or something. I'm not sure if that's what you're seeing. So if you have downloaded the zip itself from here, then you'll have something that looks like this. You should just be able to drag and drop those directly. So Rohini, if you could let us know if, like, what method are you using? Did you use the zip or are you doing it directly out of the GitHub repo? Yeah. Oh, good. Thank you for confirming, Nadia. Oh, you got a file corrupted error from. Is that from GitHub or Serial? How interesting. And here again, for those who need it, if you go to the repo itself and you go to clone or download, you can do that. Or the master zip. I saw someone just, yeah, yeah. I'm not on Windows, so I can't do it exactly, but you would download the zip and then extract it. By the way, even though I encourage everybody um, not to use the hints, if you can struggle through it, some of them in some of the areas are actually quite funny. At least I think they are. So, not that one, the one I was just showing, but some of the solutions get a little funny. Anyway, I just wanted to point that out. If you want to laugh, there's some funny ones in there. Hello. My network dropped. I'm back now. Yep, done. Hello. Yeah, are we back? All right. Hey, everybody. My network decided to go to lunch, so I'm back now. Hopefully, you guys are seeing the stream. Can I get some thumbs up? Can you guys let me know that you guys? Yay. Okay, good. All righty. Well, hopefully that didn't disrupt you guys too much that all of a sudden I disappeared. Wonderful. I see a bunch of thumbs up. Excellent. I'm now on a tethered connection. Like my broadband decided it just went to lunch. So awesome. Thank you guys so much. Okay, great. Let's see. All righty. All right, let's go ahead and continue on. All right, looks like you guys can hear me again. Yep. Yep. Yeah, I had an issue with my end. My network decided to go completely to lunch. So I am back now. Hopefully you guys can all hear me. Okay, so what we were talking about before, to kind of wrap up a little bit here. I already went through all these links. All this stuff is also in the materials that are online. That last part that I was actually going to show you before I got dropped was going in, like I mentioned here, in DataStax Academy. You can go directly to the Cassandra Developer Workshop. We do have those links that are in the GitHub repository, and we've dropped them in the room. Okay, and again, if you missed it before, I just want to repeat this part, right? Again, with COVID-19 and everything that's going on, we recognize that there are plenty of folks out there that may need some help right now with their Cassandra clusters. So DataStax right now is offering free office hours, free health checks on your cluster, and that kind of deal at no charge. So if you just email keepcalm@datastax.com to get that support. And then I mentioned before in DataStax Academy, there are a whole set of courses. This isn't all of them, but really for those especially who are here right now, right? If you're interested in getting a deeper dive, 201 is definitely awesome. 210, right? If you really want to get into some of the intricate details of how Cassandra works and what makes it so neat and everything, those are really good courses for that. You can see there's a data modeling one here as well. There's things like graph and stuff. So again, these are all free, and you can take a look at those. Killer Video is, I mentioned it today, it is one of the reference apps that we build here on the Advocate team. So what we do with these and why we build them is, one, it helps us. I mean, we deploy this for real. You go to killersvideo.com or whatever. It's a real deployed app up on AWS and other cloud resources and such. We build these real apps to try to mimic as much as possible what it looks like for the types of applications that you are all building, right? And that informs a lot of what we end up doing in the code. But the point of it really is to provide a jumping off board, a learning platform when developers are getting new into something, right? To see some examples, some real concrete actual implemented examples. Killer Video is implemented in C#, Java, Node.js, and Python, right? So we do maintain those across, and it's a good way to get some examples of some things. Something else I'd be totally remiss if I did not mention. Let me add this in to the main chat. Our upcoming events. So if you guys liked what we did today, or if you like this kind of format, right? We have more coming, and it's not just the material that we're doing today, right? So we do have more of these Cassandra workshops that are coming in the future, but pretty soon we're going to have a workshop with machine learning Cassandra and Spark, and the Cassandra Kubernetes operator. All workshop, hands-on stuff. We also have upcoming what's new in DSE 6.8. So if you want to see what's going on there, this is a webinar format, so it's not the hands-on workshop piece, but that's coming as well. You should see the links that I dropped right there in the main chat. We'll have all the links that you need for those. And with that, thank you guys so much. Just a couple last things. Again, don't forget to either direct message Jack Fryer, or email him if you want to get your vouchers. And with that, thank you guys all for coming on today. I really appreciate it. And we'll go ahead and we'll end for the today. So again, I appreciate all of your attention and everything. And have fun with your Cassandra clusters. Take care, guys. Hello. So by the way, so we are done. I almost forgot something very important is that there is a survey that we have for you guys, and we would love it if you guys would fill out the survey. We'll drop that in here as well because we really take that seriously. Be frank, good and bad. We use the information we get in the survey to evolve our content and to make it better and everything like that. So I'm going to drop a survey in, and please take a look. Anyway, now I'm really done. Thank you, guys.